the classic tricky question, and I'm pretty sure many students will get these kind of questions wrong when they first encounter this. Let's have a look. A rectangle's length is increased by 20% and its width is decreased by 20%. The question is asking us what happens to its area. At first we might be thinking, okay, the length is increased by 20%, but the width is decreased by 20%. So one up, one down, and they are both 20%. So nothing should change, right? Well, in fact, that's wrong. Something did change to its area. Well, what is it? Well, you should pause the video now and try it before you watch the solution. Ready? I'm going to tell you guys the answer here. The area is actually decreased. Yeah, it went down a little bit by 4%. Yeah, so you see one thing goes up by 20%, the other thing goes down by 20%. You don't just break even. And this is not just about rectangles, because I know many people might not even care about rectangles. But if you're talking about your stock portfolio, let's say yesterday your stock portfolio went up by 20%, which is very nice. However, today it unfortunately went down by 20%. Unfortunately, that is not break even. I will have to tell you that is a decrease of 4%. It's the same situation. So this is a very common misconception of percentage. Now, let me just show you guys like a quick way to answer this, and I'm going to show you guys the general way to work this out. And I'm just going to give you guys an example first. The easiest rectangle is a square because all the sides are equal, and the easiest square is just all sides equal 1, right? And let's say we have centimeters, because I know people would like me to put on the units. Well, the area is just going to be 1 times 1, which is 1, and then we have centimeters square for the, well, square centimeter for the unit. Now we have the new one. Well, how do we get the new one? This is not IC, this is not IM, this is CM. The new one is that this side is increased by 20%. Let's say this right here is the length. So 20% of 1 is 0.2. Here's the deal. This is the 1, and we have to go up by 0.2. So this is the new length. And for the width, which is decreased by 20%, so it's going to be shorter, something like this. 1 decreased by 20%, we have 0.8. So this is what we have. This is like 1.2 times 0.8. So the area is just going to be 1.2 times 0.8, which is let me just say area is equal to 0.96 centimeters square. If you find the difference, the new one minus the original, you can see that the difference is decreased by 0.04 centimeters squared. Compare that with the original area, which is just a 1, is 4% of the original. Yep, I just want to do the general case for you guys. Let's say we have a rectangle like this. I'm going to call this L, this W. So the area is just L times W, length times width. So this is the original. Now what we'll do for the new one is we will increase the length by 20%. So this is the L, and we are going to increase that by 20%, which means we are going to add 0.2 times the original length. So we add 0.2L. L plus 0.2L, the whole thing is now 1.2L. And in fact, whenever you increase something by 20%, it's just 1.2 times the original. So that's the quick way to think about it. Now, similarly, we are going to decrease the length by 20%. What we need to do is just take the original width and decrease that by 20%, right? So this is the missing part. So this right here will just be 1 minus 0.2, which is 0.8. times the original width. So if we finish this rectangle like this now area, it will be 1.2 L times 0.8 W. And as you can see, when we multiply this out, 1.2 times 0.8, work out the numbers first, we get 0.96. And then we just multiply the variable. So as you can see, this is the original one. And this is the new one. And we can see that from L times W to 0.96 LW, this is a decrease by 4%. And that's it.